Today we look at assignment 5, solving a triangle. We're continuing from where we left off in the previous lesson, solving a triangle. And in that lesson, we looked at a few examples and solving a triangle, finding the sides, the angles. And just to recap, we use to solve these triangles three things that we've used in the past in lesson 1, 2, and 3. So we'll use the rule of 180 rule. And the 180 rule we call it's where you have in any triangle the sum of the angles, angle A plus angle B plus angle C is equal to 180 degrees. So if we know one angle, if we know two of the angles, then we can find the third angle by subtracting it from adding the two that we know and subtracting them from 180. So if we were to know this, let's say this is 70, this is 60 degrees. To find angle A, so angle A would be 180 degrees minus 70 degrees minus 60 degrees. And that will should give us 50 degrees. So you have 180 minus 70 minus 60, and it's 50 degrees. So we can say this will be 50 degrees. That's the rule of 180. Then we looked at the Pythagorean theorem. It says that if we have a right angle triangle, and only applies to right angle triangle, the square of the hypotenuse, which is along the side here, is equal to the square of the other sum of the square of the other two sides, the A square, B square. And then we looked at the three trigonometric ratios. So they're all interconnected, and there are three of them. The three are cosine, sine, cosine, and tangent. And the sine is the length of the opposite side divided by the hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Sorry. And here's an angle and how the sides are labeled. And remember there's an acronym to remember this, which is SOHCAHTOA, which is, you read it here, SOHCAHTOA. Okay, so we'll be referring to these three whenever we are solving a triangle. So let's look at example 1, and I've separated them here. So we have example 1 and 2. So they ask you to solve the following triangles where necessary, round side lengths to two decimal places and round angle measurements to the nearest degree. So let's look at the first one. The first step we take is to label the sides. So in this case, there's no indicated angle. So I'll just make a reference angle. So that refers to angle B as theta. So we have two sides. So once we know we have two sides, it's easy, we can apply the Pythagorean theorem, because once we know the measurement of two sides, we can find the third side using the Pythagorean theorem. So we'll label these. It's going to be side C. Now notice when you have an angle, the side C here, this would be side A. Now, the way you label the sides, you look at the label of the angle, and the side opposite the angle is indicated with the smaller letter, or the lowercase letter. So A, this is angle B, so this is going to be side B. And the hypotenuse is opposite the 90-degree angle. We'll label it as psi c. So we're going to find side c. So c square using the Pythagorean theorem. So we can say we're using the step 1, the Pythagorean theorem. C squared is equal to a squared plus b squared. So we're given a, so a is equal to 42, b is equal to 37, and we need to find c, we don't know. So the c squared is equal to 42 square plus 37 square. So c, we get our trusted calculator. So we have 42 square plus 37 square gives us a total of 3133. So c squared. Now solve for c. Now c is going to be equal to the square root of 3133. So c, take a square root of 3133. Gives me 55.97. That's feet. So c is 55. So I can highlight my solution. Now we know 3 sides. We could now, to find the other missing angles, we just need to find one and then use the 180 rule. So to find a missing angle B, theta here, angle B, we'll have to use one of the trig ratios. So find angle B, use the trig ratio. So what is given? We have, now we have to label the sides. So this side will be the opposite. This will be the adjacent. So I'll put that in here. So it looks kind of less cluttered. Opposite side. So now we have opposite and adjacent, and we need to find theta. So we look to our trig ratios where we have opposite and adjacent, that's tangent. So we're given opposite which is equal to 37, and the adjacent, which is equal to 42 feet. And we need to find theta, which is angle B. So we make a reference to our trig ratio, and we look for opposite and adjacent, and there'll be tangent. So this will be tangent theta is equal to 37 opposite. I'll just write out the trig ratio here. So tangent theta is 37 divided by 42. Now we have to use our calculator. So remember, we need to find the angle. We have to go to our second or shift key in our calculator. So I'll clear that. So I need to press in my case, I'll press the second button. Now, you may have a different scientific calculator. In your case, you might see inverse button, I and V, but most of them will have the second button. But I and V simply refer to the same as the second button in this calculator. So I'll press second, then I'll press my tangent. And always remember, you must be in degree mode. So go back to, so I have 10, 37 divided by 42. So 37 divided by 42, close bracket, press enter. So that would give me, so angle B is equal to 41.38 degrees. Notice I'm around decimal places. Although they ask us to put in nearest degree, I will continue with 2 decimal places because in applied math, the reference is 2 decimal places. So this theta now, we conclude, is 41.38 degrees. So I'll indicate it up here. So that's my angle. And notice, once I know 2 angles, I can find the third angle by using, you guessed it, the 180 rule. So I have 41.38 degrees, I have 90 degrees. So, or you can basically, we know this is 90 degrees, these 2 angles here add up to be 90. So be 90 minus 41.38 would give us angle A. So we can put that here. Use 180 degrees rule. Angle B is equal to 90 degrees minus 41.38. Or you could go ahead by saying 180 minus, or angle B is equal to 180 degrees minus 90 minus 41.38. And you'll end up with the same value, which is 48.62. So angle B is equal to 48.62 degrees. Oh, so that's example 1. So question 2 is very similar to question 1, because here we're given, again, 2 sides. We can go ahead and using the Pythagorean theorem and find side G. So leave us a side G here. This will be side K, and this will be side H. Now, I will go ahead and I will label this angle here as my missing angle because I need to find all 3 angles. So label it to say this. If I label this as my missing angle, this becomes the opposite side. This now is my adjacent side. And K would be my hypotenuse. So step one, let's find the side. And it's similar to what we did earlier using the Pythagorean theorem. Then we're going to use the trig ratio. And then we're going to use the 180 rule to find the third angle. Okay, let's move right along here. So let's look at the Pythagorean theorem here. We're going to look step one, finding side G. I'll just straight line them here so I can So we'll use the Pythagorean theorem, so which is, in this case, we'll have k squared is equal to g squared plus h squared. We have k squared is 51 squared. G squared, g we don't know, so we have to leave that as the unknown, plus h, 42 squared. Now, let's work these out. We have (51 squared) is equal to 2601. We don't know what g is, so we leave it alone, and we have 42 squared equals 1764. Now we need to isolate the g squared. So we'll take the 1764 that's on the left and move it over. Sorry, it's on the right, but move it over to the left. So the way we do that, and this is the logic behind 2601, is equal to g squared plus 1764. I'll subtract it from the right. And also I do exactly that on the 1764. So I'll highlight it, showing you that by subtracting it, I must do exactly what I've done on the right side on the left side. By doing that now, this becomes 0. So this becomes 0, so I'm left to 2601 minus 1764 equals g squared. Do my little magic here, subtract those two, so I got 2601 minus 1764 gives me 837 equals g squared. Now, if you're not happy having the unknown on the right, you can switch it over to the left. Could be written as this also. G squared is equal to 837. So now g, I'm going to square both sides, square with both sides. So I have now g is equal to the square root of 837. So I'll do that in my calculator, 837, and gives me a result of 28.93. So G is 28.93 inches. So now we move on to finding this angle here. Now I know all of the sides. I could go ahead and use any of the trig ratios, but I always like to use the ones given. In this case, the two sides get opposite and hypotenuse. But you could also use adjacent and hypotenuse, adjacent and opposite. You also will give you the same result. So I'll go ahead and use what's given. So I'm using, so find angle H. So use a trig ratio. So what is given? So we have theta is, we need to find theta, which we don't know. Well, we're given the opposite side, which is equal to 42, and we're given the hypotenuse. Or we're just using these two sides, but we have found the other side. Then I go to my trig ratio and see where opposite and hypotenuse matches. Opposite and hypotenuse is sine. So I'm going to use a sine ratio, sine theta. Or in this case, angle H is equal to the opposite, which is 42 divided by 51. Now this is where I'm going to use my calculator. Put second sine 42 divided by 51. And press your equal button. And it gives me a result of, let's go to my calculator here. Let's see, how does it work out? So we have clear everything off my screen. I have second sine 42 divided by 51 gives me a measurement of 55.43 degrees. So 55.44 actually. So you're rounding. So let's highlight. So we can say this is 55.44 degrees. So we highlight our answers. Now we need to find the missing angle G. So this is where we use our rule, the 180 rule. So 55.44 degrees. So we can say that it's angle H. Now to find, use the 180 rule. Find angle G. So angle G is equal to 90 degrees minus, and we're given an angle of 55.44 degrees. So angle G is equal to, we do the wonderful math here, This gives us what, 34.56 degrees. Let's verify that in our calculator. Okay, so that's our final measurement. So recapping, we're asked to find the missing side. We use the Pythagorean theorem. Let's be here. Pythagorean theorem. Then we use the trig ratio sine. So over here we use tangent to find our angle, and then we use the 180 rule. So trig ratio, 180 rule. And this will be a continuous theme throughout this section of the course, solving a triangle. I'll go through two other examples. Five and 6. And the other ones, I'll post the full solutions on the blog. So let's go on to question 5. And notice kind of and the reason why I'm doing these is to show you that even though the orientation is not what you may expect, nevertheless, it's just a right angle triangle as long the symbol is indicated here, this right angle symbol. That's a right angle triangle. So we're given the two sides for this first one here, and the other one we're given a side and an angle. So this works out nicely. Now we're moving into the ones where they have an angle and a side. Oh. So I'll separate these two here by putting a line through here. Now this is similar to what we've done before, so I'm going to go on to this question here, which gives you an angle and a side, but you need to find the other two sides. Now, first thing you'll notice, you know two angles. So it's a reverse now. We'll use the 180 rule to find our third angle, or the missing angle, which is angle. So we put theta here. So step 1, we find our missing angle using the 180 rule. So step 1, finding, use 180 degrees rule to find angle S, because we already know two angles. So that we, now because it's a 90, we simply have to subtract. So angle S is equal to 90 degrees minus 19 degrees. So angle S is equal to 71 degrees. So put in here 71 degrees. Okay, so that was an easy start. Now we have two missing sides. Now, because you know all three of the angles, you have a lot of options here. But as I said before, I like to use what's given, even though what I discovered. Although there are times when you need to find a missing angular side to proceed in the question. We look at some of those in lesson 6. But for now, let's assume we want to find side here. Now, next step we'll do is label the sides. So this is I'll use this angle here as my reference angle. So this becomes the opposite side. Now, if you were to go ahead and use the angle that we discover or we determine, then this will become the opposite side. So notice this is my opposite side here. Now, the 151 yards side will be my adjacent side. And the side opposite the 90 degrees will be hypotenuse. So let's find the opposite side. And we label that as, it'll become labeled side T. So to find side T, use, in this case, opposite, we know opposite and adjacent, you'll be using our tangent. Okay, so we have use 10 ratio. So we have 10 theta is equal to opposite over adjacent. So we're given opposite, which is equal to, we don't know what that is. And so we need to find that, meaning we're given theta, which is 19 degrees, and we're given the adjacent side, which is equal to 151. In this case, yards. Get some space here, running out of space here. So equals 151 YDS. So now I'll substitute the values into here. I'll refer to this as opposite side as side T. So it'll be 10, 19 degrees. Equal to T over 151 yards. So T, now here, we'll do a little algebra here. So T, and I'll work this one out to show you the reasoning. Now I want a T by itself. Let me try this somewhat better here. So we multiply by the reciprocal of this 151 over 1. So I must do exactly that on the left side. So 151 divided by 151 is 1. So we have 1 here. So we left with T is equal to 151 times 10, 19 degrees. So you can do a cross multiplication and arrive at the same thing, simply cross multiplying. But some people prefer the cross multiplying rule, which I'm not a fan of, but it works. You can have 10, 19 is equal to T over 151 is equal to 1. And then you cross multiply these. So you have 151, 10, 19 is equal to T times 1. And you'll end up with the same result. Well, this is the mathematical logic behind it. So now we have t, and if you don't like t on the right side, switch it over. So t is equal to 151, 10, 19 degrees. So let's work that out in the calculator. So, so 151, 10, 19, 51.99 yards. Okay, we need to find the hypotenuse. We can go ahead and use the Pythagorean theorem, and we'll end up with the same result. But I'm going to use another trig ratio because it's more fun, and it's also give you a lot of practice. So to find, in this case, we'll label the side, the hypotenuse will be u. So to find side u, use trig ratio. So what trig ratio will we be using? We know 151. We also know the opposite side, but I'm going to use what's given. And what's given also is the angle of 19 degrees. So I have the angle and I have the adjacent side. We need to find the hypotenuse. So adjacent and hypotenuse, that'll give me cosine. So I'll use a cosine ratio. So cosine theta is opposite, adjacent, that's sine. So ADJ over HYP. So we have cosine, so theta is 19 degrees, and we have the adjacent side is 151 yards. And we need to find the hypotenuse, which is u. So cos 19 degrees is 151 over u. And in this case, we'll do our algebra, which is cos 19 is equal to 151. Oops. Over u. So I'm going to multiply. Now, cross multiply. So we're more or less switching these as a shortcut. I'll show you the reasoning behind it. So you multiply this by u, multiply this by u. So the u is gone. I'm trying to isolate the u. So the u, which is my unknown by itself. Now I have u cos 19 is equal to 151. Now I need to divide both sides by cos 19 degrees. So u is equal to 151 over cos 19. So side u, and I go to my calculator here. And I go 151 divided by cos 19 gives me a measurement of 159.70. So 159.70 yards. So there you have it. Using the trig ratios, the rule of 180, to find our final measurement. So, okay, so we'll record that on side 159.70 yards. Okay, I'll do one other example, and which is a little simpler one. That's question 3. This is a nice orientation here. So we'll find angle D. Now this was because we know we're given 2 angles, 90 degrees, and so angle D is 180 rule. So angle D is 90 degrees minus 59 degrees. So angle D is equal to 31 degrees. So this is 31 degrees. Now we'll look at finding the hypotenuse. And this is where I'll need to look at my trig ratios. I'll put it right as here. So I'm going to label this side as side F, and this would be side D, small letter. So side F, use trig ratio. So what are we given? We are given angle theta, which is 59 degrees, and we're given the opposite side here. So we know this is the hypotenuse we need to find. So we're given the opposite, because we're referring to this angle here. So opposite equals 26, and we need to find the hypotenuse, which is side F. So where we have hypotenuse and opposite, it would be sine. So we'll use the sine. So sine theta is opposite over hypotenuse. So sine 59 degrees is equal to opposite, which is 26 over F. So F is equal to 26 divided by sine 59. So F is equal to, my calculator here, 26 divided by sine 59 gives me a measure of 30.33 millimeters. So this is 30.33 mm. And we'll find the adjacent side now, and we'll use the trig ratio, side D. Now, we're looking at side D. We have, this would be adjacent, and we know the hypotenuse, and we know the angle. Sorry, this is opposite. Sorry, we know the opposite. We also know the hypotenuse. We could use it also, but I'll use the opposite. Use trig ratio. So we are given theta, which is 59. We also have theta as 31. If we were to use 31 degrees as my reference angle, this becomes the adjacent. This would be the opposite. But since I'm using 59 degrees here, the opposite side is 26. And the side I'm finding now becomes the adjacent. So we give an opposite, or we're using the opposite, I should say. And I need to find the adjacent, which is side D. Then I go to my trusted trig ratios here, where I find adjacent and opposite. Because if you go back here, we need to find the adjacent, and we give an opposite, noting the angle. So adjacent and opposite would be tangent. So we tan 59 is equal to opposite, which is 26 over D. So D is equal to 26 divided by tan 59. So D, go to my calculator now. 26 divided by 10, 59 equals 15.62, and that is millimeters. So there we have it, the process. We use a 180 rule to find the third angle when we know two angles. We use the trig ratio, the sine, when we need to find the hypotenuse. And to find the adjacent side, we use the tan ratio. So the other questions, questions 4, question 5, I'll post those on the blog. Yeah, sorry, the complete solutions to question 4 and 5, I'll post those on the blog.